Okay, so let's learn about chemical energetics. Here are the learning objectives. This chapter will talking about lattice energy and Born-Haber cycles. First, define and use the terms of enthalpy change of atomization, or the symbol is delta HAT. B, lattice energy, or delta H flat, or the change of gas phase ions to solid lattice. And then two, A, define the use and use the term of first electron affinity, or EA. And B, explain the factors affecting the electron affinity of element. And C, describe and explain the trends in the electron affinities of the group 16 and group 17 element. And yeah, let's talk about it one by one. Let's first talking about the enthalpy change of atomization. For understand the meaning of enthalpy change of atomization, you need to understand the definition itself. So it will be easier for you to convert or to write down the chemical formula uh, for the enthalpy change of atomization. So here is the definition. Okay. So the enthalpy change of atomization is the enthalpy change when one mole of gas atoms is formed from its element under standard condition. So if it is hard for you to analyze, I'm going to show you the example. So for example, we use sodium element. So sodium in their standard condition is in solid. So it start from sodium solid. It will produce the sodium in gas. So the product for the atomization, it should be in atom and it should be in gas. So easy, yeah? So just write down the element in atom and it should be in gas states. And then at the end, don't forget to write down the symbol delta HAT0 and write down the data. That's for the enthalpy change of atomization. Next, the lattice energy. So based on the definition, lattice energy is the enthalpy change when one mole of an ionic compound is formed from its gas ion under standard condition. For example, Mg plus 2 gas plus O negative 2 gas, it will produce MgO solid. So mostly ionic compound is in solid. So you need to know how to write down the ionic compound. If it contains the index, please don't forget to write it down. Okay. Next, talking about electron affinity. Electron affinity is the enthalpy change when one mole of electron is added to one mole of gas atom to form one mole of gas ions, each with a single negative charge under standard conditions. Here's the example. So it is in the neutral condition first in gas. It will attract one electron. It should be one by one. And then it will produce the negative ion and it's still in gas. For the electron affinity, it can continue again as long as we still have an electron. So it can be the EA1 for the first electron, EA2 for the second electron, and so on. And once again, don't forget to write down the data. So delta HEA at the end, and then write down the number. Now you need to know what factors that affecting the electron affinity. First, the value of the electron affinity depends on how strongly the incoming electron is attracted to the nucleus. The greater the attractive forces between the electron and nucleus, the more energy is released, and therefore the more exothermic or more negative the EA first value will be. Number two, the factors affecting the electron's affinity of an element are the same are those that affect the ionization energy or the formation of positive ions via the loss of electrons. And about the nuclear charge, the greater the nuclear charge, the stronger the attractive forces between an incoming electrons and the nucleus. About distance, the greater the distance between the nucleus and the outermost shell or orbital where the electron is added, the weaker the force of attraction. And the last about shielding, the greater the number of shells, the greater the shielding effect and the weaker the force of attraction. Okay, so based on that factors, can you guess what's the trend of group 16 and 17 in electron affinity? Let me show you the data. Now I'm going to asking your analyzing skills to find the trend of electron affinity. Okay, so yes, it's your time to analyze. I think we can discuss about your idea or your feedback on finding the trend of electron affinity for these two groups. And yeah, we can share your arguments, and you can also like hear your friends' feedback for finding the electron affinity trend in our next session. So I think for today's is enough. Let's close with saying Hamdalah together. Alhamdulillahirabbil alamin, and see you on my next video. Bye bye. Assalamualaikum warahmatullahi wabarakatuh.